All right, guys. Well, we're back with 11.2. It's short and sweet.
Yeah, pretty quick.
You know, just two other shapes here, or three other shapes here. Two of them are kind of closely related, but anyways, I mean, pretty straightforward. And like the other ones,
again.
Formulas.
Plug it in.
Yeah, if you know what a base is, you know what a height is, you're pretty much good to go. So
Yep.
we're looking at a trapezoid, a rhombus, and a kite. And so, I mean, pretty basic. Trapezoid's one of my favorite shapes. I don't know why. I just like trapezoids. You know, anyway, I don't know. Got anything? And
No. The formula for a trapezoid is kind of interesting that you can look at it a couple different ways, and so we'll do that as we get into it here.
yeah, but I mean, at its heart, but before we get into the formula, just remember once again, guys, that the height is the distance between the bases here on a trapezoid. Okay, and then the D stands for a full diagonal. When we look at when we look at a trapezoid or a kite or a rhombus, the D is the full diagonal from one corner to the opposite corner of the shape. Okay, not halfway to the middle.
And when we're still looking at the height, it still has to be perpendicular to the bases.
Yeah.
Yep.
It's just on a trapezoid you have parallel pieces, and rhombus too. So
Yeah.
just pay attention to those things, and it shouldn't be too bad. But area of a trapezoid, guys, is just one half the height times the sum of the base 1 and the base 2, which is the two parallel pieces, the top and the bottom parallel pieces. So you got to look for those two parallel pieces. Those are the bases. That's kind of the key to being successful when you're doing a trapezoid, is to understand that base 1 and base 2 are the parallel pieces. It doesn't really matter which one you call base 1 or base 2, as long as you get that it has to be those parallel parts.
Yeah. Another way of looking at that formula, guys, is if you move the H maybe to the end or whatever, the 1/2 of B1 plus B2, that's the average of the bases. You just add the two bases together and divide by 2. That's the average of the bases. If we drew a line, a mid-segment through the middle of that trapezoid, that would be the length of that mid-segment. It's just half of the two bases added together. So you take the average of the bases and multiply it by the height, and that's the area of a trapezoid. So,
which is kind of handy too, because sometimes the height may be an odd number, but the addition of the bases is an even number, so you can cut that in half real easy, and then just multiply it to the height. So it kind of gives you some room to kind of operate, to kind of simplify it.
Remember your rules of multiplication there.
Yeah.
To cancel that 1/2, cancel that 2 down there, you only want to cancel it with either the H or the two bases added together, not both.
Right.
But you want one of those to come out even so that you can cancel that. If they're both odd, then you're going to have a fraction for an answer. So.
And then when we look at a rhombus, that's the yellow shape, and then the kite is the blue shape down there. The area of a rhombus is 1/2 the diagonal times the other diagonal. It doesn't matter which one you call diagonal 1 or diagonal 2, but you got to multiply them both together and cut it in half. Or same thing like with the trapezoid, if one of the diagonals is even and one of the diagonals is odd, you can cut the even one in half real quick and then multiply it to the other one, and you're good to go.
And that's a rhombus or a kite?
Yes,
formula?
yeah, same exact thing for a kite. They work the exact same way. You can do the same thing on a kite. That's why they kind of have one shape under the other, because the formula is used for both. So when you're doing a kite, guys, it's the same formula for the rhombus, which is important. So make sure when you go to label this in your notes that you have both of those pictures in there, because they both use the same formula. So rhombus and the kite both share that formula.
And what's unique about the diagonals in those two shapes is that they're both perpendicular to each other.
Yep.
So, yeah.
Well, here's a few examples of them. So here we have a rhombus. We can tell it's a rhombus because all four sides are the same. And so you got to be careful here now, because remember, in the yellow at the top of the PowerPoint, it said that D stands for the full diagonal. So if you look at this rhombus here, they're only giving you partial pieces of the diagonals. Okay, for the vertical diagonal, they only give you halfway. So the full diagonal is 60, and on the horizontal, the full diagonal is 80. So you can cut the 30 in half, or cut the 60 in half, and now you're back to 30. 30 times 80 is 2,400. And so there's your answer, or here's the formula right here. Area equals 1/2 the full diagonal of 80 times the full diagonal of 60. You can cut either one of those in half, and you get back to 2,400 meters squared. Okay? And then for a kite, they have one. Now this is the thing where you have to be able to look at this, guys, and say, okay, that diagonal, if I take that 14 inches and I just raise it up here, and that would be right in the middle there and kind of slides it across. You have to be able to visualize that. So the full diagonal on the horizontal for the kite is 14 times the vertical diagonal would be 6 inches. So the formula becomes 1/2 of 14 times 6. And for me, when I look at this, I'm like, okay, well, which of these numbers makes my next step easier to do? So rather than cut 6 in half and do 3 times 14, I would rather cut 14 in half, because 7 times 6 is easier for me to quickly get to the answer than 14 times 3. So 7 times 6 is 42, and then that's inches squared. Don't forget those units, guys. Those units are really important.
Yeah, maybe it's clearer here. Probably in the yellow box, it would have been nice if they would have put 14 inches and 6 inches. The fact that you're multiplying inches times inches, that's where you get the square inches from, or
Right.
inches squared.
Right.
So remember, you're multiplying those in area, and area is always measured in square units. Okay? Okay, just a couple more examples. This one happens to be on a quadrant system, or a Cartesian plane here. And so we're trying to find the area of that trapezoid. And so if we think about that formula for the trapezoid, we need the height, and it has to be perpendicular, and we need the 2 bases. So we can just count boxes here. So if you look at the bottom of that, we're counting over 1, 2, 3, 4, 5 spaces, 5 boxes, and so the bottom base is 5. Look at the top base, it's only 2 units long, so the 2 bases are 2 and 5. Okay, the height, if we count again a perpendicular to that along the y-axis, then the height of this trapezoid is 3 units. And so we would just plug all those into the formula for a trapezoid. And so we're going to get 1/2 of 3. Again, 3 is the height. The 2 bases are 5 and 2. So we're going to add those 2 together. Now here's an instance where both of them are odd. So we're not going to be able to cancel the 2. And so it's just going to be 3 times that 7 is 21. And the answer is just going to be 21 over 2, or 10.5 square units. Now we don't have inches or meters or whatever here, and so it's just square units. So 10.5 or 21 halves. Okay, so we're just counting boxes when it's on a Cartesian plane. Okay, here's another one. What did you say you call these?
Composite shapes.
Composite shapes. So we're going to have to put some things together here. And if you look at this, it's really a rhombus in the middle there. On the left-hand side, that shape is a rhombus. And then on the right-hand side, it is a parallelogram. And so you could break it up that way. You could break it up in smaller parts if you want to. Bless you, Mr. Bedell. You could break it up into smaller parts if you wanted to, all those triangles and so on, but there's no need. That's just more work. So let's see where they start here.
I see a trapezoid and a triangle.
Trapezoid and a triangle?
Yeah, right there on the top, trap, and then the triangle on the bottom.
Okay.
Just me.
Okay. No, that's fine. Yeah. See it different ways?
But the easiest way is what Mr. Scritchfield said first, with the parallelogram and the rhombus. That's the best way to solve it.
Okay. And we got to pay attention to the hash marks here as to what's
oh
congruent.
my gosh, it's really
because they only give us 2 sides.
Right.
But there's so many sides that are equal here. And so all the single hash marks are 4s, and all the double hash marks are 5s. And so the single hash marks are 4, double hash marks are 5, and so that sets up a right triangle inside there, with the hypotenuse being C, being 5, and one leg of it being a 4, and so it's a 3, 4, 5 triangle, if you know your Pythagorean triples. If you don't know that, plug that into Pythagorean's theorem and calculate it. But that height ends up calculating out to 3 from that right triangle. Okay, and so we end up being able to get the full diagonals then, because top and bottom are 3, and so that vertical diagonal is 6. Horizontal diagonal would be 8, the 4 and the 4. Okay, so we can find the area of that rhombus by doing that. And so it's 1/2 the 2 diagonals multiplied, so it's 1/2, that's 6 times 8, so 3 times 8 would be 24 for that one. Okay, then we go over to the parallelogram, and the area of a parallelogram is just base times height. And so you have to be careful here, because we're looking for a perpendicular height. So if we look at that 4 on that right-hand side parallelogram over there being the base, then the height, perpendicular height to that, would be that 3 still. And so the base times height here is just going to end up being 4 times 3. And so it's 12. And so as we add those together, we end up getting 36 square units for this overall composite shape here. Okay, so all that tan color area ends up to be 36 square units. All right.
If you guys want, for fun, if you saw it a different way, just try it a different way. If you wanted to do the area of that trapezoid on top and then add the area of that little triangle on the bottom, you're going to get the exact same answer. I mean, there really isn't any set way to do this. You could do the triangle plus the parallelogram and still get to the exact same place.
Yeah,
I mean, it's
or
just,
the 4 triangles in the parallelogram. It doesn't matter how you split it up.
it's always going to be the same.
As long as you split it into pieces that you actually can find the area of.
Right.
So, okay. One last example here, I believe. So now we're talking about a kite. It's interesting that they put the kite within a parallelogram here. Okay. But we're trying to find the area of that kite. And so the 7 here basically could be slid over to the one diagonal of the kite. The 12 at the bottom could be slid up to the other diagonal of the kite. And so the formula for a kite is the same as the one that we had over here for the rhombus. It's 1/2 the two diagonals multiplied, or 1/2 the product of the diagonals. And so if we just multiply those two together, 7 times 12. Oh, I'm not reading this right. I'm sorry. The 10.
Yeah, there isn't any direction on there. Yeah, I think
Yeah,
that.
the tan area is what we're looking for. And I don't know how well you can see that, guys, but basically it's the area of the parallelogram minus the area of the kite. And we're going to have some questions like that.
Yes, and I was going to say that. Yeah, I mean, these are going to be the ones where they want to know what's left of the paper if you were to
Right.
cut that out.
So it's kind of opposite of the composite thing.
Right.
Instead of adding pieces together, we're having a piece with like a hole taken out of the middle
Right,
of it,
right.
of a different shape.
It's like a donut.
Yeah, and so it's an odd-shaped donut, but yeah. And so instead of like trying to find the pieces of all those little triangles to find the tan area there, we would just take the area of the parallelogram, which is the 7 times 12, and then cut out the kite, which is where I was. And so if we look at the area of the kite, it would be 1/2 of the two diagonals multiplied. And so you would subtract those two, because again, we're cutting the kite out of the middle of the parallelogram. So the parallelogram, 7 times 12, so that's 84. 1/2 of the 7 times 12 would be 6 times 7, so 42. It's actually half of the area. And so it ends up being 84 minus 42, or 42 square units here. So you really have to pay attention to the shaded area of the shape in terms of what they're asking you to find the area of. So be careful with that. All right? Okay, we'll look at some more examples in class, guys. We'll see you then.